Good morning, everyone. Thanks for joining today's session. I will, just to let you know that, as you may know, yesterday we have some issues with the installation of a library. I fixed them by installing because I have an old version of R and an old version of R Studio. I update everything yesterday afternoon, so it seems that the problem is it's solved. So my plan today is to cover the contents that we couldn't teach yesterday, and also finish the contents that are planned for today. So I have a look, and we will have a time to cover everything. So there is not a problem with that. So what I will do is I will share my screen. Okay. Also a reminder, if you have any question, comment, etc., please feel free to type it on the chat, or raise your hand and unmute yourself. So the plan for yesterday was to read a CSV file, and where the issue was to install the tidyverse library. That library is a set of many other libraries. So when you install that library, it takes some time, and is a little bit well, time consuming. And for my laptop, it took some effort to install the library. But once that the library is installed, it includes all the packages that we will use today. So let's start loading that library. To load the library, we need to type library and then tidyverse. So you can see, well, first a question is the font size okay? Can you see that, or do you want it bigger? Great, thank you. So yeah, it's okay. If in case that at any point is not okay, please let me know. I didn't say, yeah, I installed the latest version, that is our version, the 403. And well, you can see when we load the library tidyverse, that all the libraries or packages that are loaded, that is ggplot2, tbol, tdr, you have all of these. And we have here two conflicts. What that means is when you type filter, for example, it uses the function that is in this library deploy, rather than the function that is in stats. So this is a warning. So for example, if you want to use that library, sorry, data function filter that is in the stats library, you need to write the you need to write this. You need to write the name of the library, two columns, and then the name of the function. If you write only this, you will execute the function that is in that library. this question was asked yesterday, and yeah, this was the problem. That it's a warning that if you type only filter, the function will be executed from this library, from the deploy library, rather than from the stat library. So once that we have loaded this library, we will read the the surveys file. So if we type where the file, we will save that in a variable called surveys. We type the assignment operator, and then we use read underscore CSV. What is well, yesterday it was at the question, what is the difference between this command and this one, that is read.csv. I have seen this is this first command comes from the tidyverse library, and this second command comes from the generic library on R. And I read that the first function is more efficient than the second one. So we will use this function. And then, okay, what we needed to include as an argument is where our data is. That is in data row is portal data join .csv. So if we execute that, we can see that the columns that we have import. I mean, we have import a table, and the table consists of columns and that are and the observations that we have. All the observations are rows. So what this function does is read the first rows and uh, uh, guess the type of the type of each column. So we see that for record ID says that it's a double, for month, day, year, etc. And for other columns, guess that is a character. So by default, it doesn't get a factor. So get a character. Later, if we want, we can use factors. Also to mention that well, if we type head surveys, we can see the first the first rows of this data frame. Well, actually, also there was a question yesterday. There was what is a table? A table is like is a data frame, but it's like it's it's a data frame, let's say, with like this like well, easier. It's like less complex than the original data frame. The thing is, R is a programming language that have some some years old, and having a lot of improvements of this language. Tibor is a yeah, it's like a data frame, but it's like lighter than the original one. And that's why when you import data, you don't convert the data to factors. You first is converted to characters, to strings. Later we can see how we can. Also, well, with this with the latest version of RStudio, you can see that NA, that is we saw yesterday, that is not an not a number, or is something that is missing there, is in red color. So that makes to visualize everything easier. Also, if you want to see the contents of the file using RStudio, you can type view and then the name of the study. And you will see here in the top left, you will see the table that looks like a Excel. You see all the columns, and also you can see the rows. So data frames is like a table. We have you can see that we have columns. These columns have a name, and also we have observations that are in rows. Also, we can see a little bit more the structure of the data frame if we type str and the name of the data frame that is surveys. There we can see that is well actually is a table that is we have this number of we have more than 34,000 rows, 13 columns, and also we have the name of the columns, the type, and we see the first element of this column. Also to get more information about data frame, you have these functions. You have a team that is the dimensions of the service. As you see that we have more than 34,000 rows and 13 columns. Also, we have the function nRow. And the function nCall. If we want to see the first 6 rows, we can type head. Or the last ones, we can type tail. So for example, you can see the name of the columns. If we type names and the name of the data frame that's a service. And also we have there is a function that is called a summary. That what that function does is for each column you can get the minimum, the maximum, the average value, the median, etc. So you get the statistics per column. Also, this a data frame can be used as a matrix. You can get elements, and you can get the row, you can get the column, etc. So, for example, if you want to get the first element of the table, the first element that is in the first row, first column, you can use a square brackets. So you type the name of the data frame, that is a service, and you type 1, this is row 1 in column 1, sorry, 1. And there you get the, record ID 1, you get a double that is 1. You can also get the first element of the 6th column. If you type 1, 6, you get the species ID NL. And so on. Also, you can get to get the first column is you leave the row part in blank, and you type the number of the column, and you see that you get well, actually you get another data frame, as you can see here, table of 34,786 rows and 1 column. I have a question that says when trying to create a new directory, I get a pop-up which says the git command requires the command line developer tool. So this tool is not needed for this workshop. Git is to when we use, for example, GitHub repository. If we want to, keep that repository update. But yes, if it's a warning, that should be okay. But I'm not sure if there is a problem with when you create the directory, or if I mean, if you can create the directory but you get this warning, it should be okay. You don't need to worry about that. Yes, I didn't. Yeah, that's a good point. Yeah, I didn't. I have two more questions. That is, the first question is having different outputs for the commands. But I load the data has a data frame, but it looks now that your data is not loaded as a data frames. No, I mean the thing is a table is a type of a data, let's say a type or a subtype of a data frame. So you can use both of them as synonyms. The thing is when because this is a new version of RStudio, when you execute, for example, here that you get the sixth column, you get a data frame rather than the vector. I don't know if that's the question about, but mm, the thing is that is I mean you should think that is a table and a data frame are the same thing. And also what I didn't explain is how to get the data into the project. Uh, the you need to download the data. There are two ways. The first way is I will type the command in the chat. So you can execute that command, and you will save that in your project repo in your project. A manual way to download that is to first download in a folder on your laptop, and then get access to this to move that to the folder. Okay, there is a question that is when you use summary, you get okay. If yeah, we can see that later when we talk about factors, because maybe something, because I think uh, if you use the function that I will type and read dot CSV, the behavior is different. That if you use read underscore CSV. Okay, so I will continue with the. As you see, for example, here, if I type this, I get this the sixth column. But what about if I want to, well, with the data frames, I can use the name of the column instead. So I can get, I can type surveys, and then in a square bracket, I can type the name of the column. That is species ID underscore ID. You see that I get the same. But what about if I want to get a vector instead? There are several ways. One way is to use again uh, a square bracket. So well, you see that the output is different because we don't get a data frame, we get a vector. Also, another way is to use surveys, dollar symbol, and the name of the column, that is species ID. And then you get a vector again. And also another way is to type surveys, square brackets, comma, and then the name of the column, that is species ID. Oh, okay, we see that it if when you use that is you get a data frame rather than a vector. So yes, you have these different options, and you can, yeah, please feel free to use the one that looks for you more convenient or easier to remember. So yes, what I will do is I will continue with explaining what is factors. If we type, well, we can, well, I think maybe it's easier if I type again str surveys. Yes. Here you can see that the columns that are strings, for example, species ID, sex, genus, you see that these columns have like numbers that are not numbers, names that are repeated. It's like you have some let's say categories. So what you can do is you can instead of saving data as characters, you can use factors. What is a factor? A factor is you have a set of categories, and each category corresponds to a number. So this is this is normally more efficient from the point of view of storing, working, etc. So if it's possible, it is recommended to use factors. So what is a way to use that? We can change a column of our data frame. The sample that is in the documentation is called well, they work with the column sex. Also, regarding the documentation, I will share the link. I think that you already have that link, but yeah, just in case that you want to have a look or copy and paste, etc. So because we see that here sex is a column with that is a character. So what we can do is we can change that and use factors instead. So to do that is you have to type surveys, then a dollar symbol and the name of the column, that is sex. then the assignment symbol, and then you type a factor and the name of the name of the column, that is surveys dollar symbol sex. Sorry, the name of the data frame and the name of the column. So if you do that, and then you type str surveys, well, you see the here it changed. You have you have a factor with two levels, that is F and M. F is for female and M for male. And also you have a NA that is like not defined. And normally, for example, you see here F and M because it takes normally it takes the alphabetical order. So F will be 1 and M will be 2. Remember that in R we use the let's say the counting starts with 1 rather than 0. Also, you can create if you can create a factor. Let's call it sex. You can create a factor from a given vector. So if we type the assignment operator and then we type a factor, and the argument could be a vector. So the vector we can have a male, female, female, male. So if we click on that, well, you see that here on the top we have a new value that is sex, that is a factor with the two levels, female and male. Also, how can you see that if you write levels sex, you see the two levels that you have, that is female and male. And also you can see the number of levels sex, that is you get the answer 2. And when you if you type sex, you see the output is male, female, female, male, what we have introduced before, and then you see the levels that you have, that is female and male. If for some reason you want to change the order, you can do so. The way to do so is you type sex, the assignment operator, and then you use the function factor, where the first argument is you can use the factor that we had before, and then you can specify the levels. So to specify the levels, you type levels equal C open brackets, and you specify first male and then female. So if you do that, and then you type sex, you see that now the levels change. Before we have a female male, and now we have a male female. So I think it's now time for a challenge where you can play a little bit with that. So I will share the challenge. Okay. So please mind to do this challenge and this the challenge the number one and the number two, and when you finish, please type that you have finished on the chat. And if you have any question now, please let me know. Happy to answer it. Also, sorry I didn't introduce before. Today's Chloe with us is a colleague of mine at EPCC, and she's helping out with the course. Okay, first I unmute myself. I see that one person already finished the challenge. What I did is I create a poll and you can answer that poll once that you finish the challenge. I heard that yesterday some of you have issues answering that poll. So if you have that, if the poll is not working from you, just type that on the chat. Okay, what I will do is I will, while I see that some of you are still doing the challenge, what I will do is I will repeat again the steps to download the data. Because yes, I, uh, I didn't do that before. So what I will do is I will share my screen. Well, my screen, the screen where RStudio is. So if we start from the beginning, if you are in RStudio, you see that RStudio is divided in four, and if you go to the bottom right, you can see a tab that is called Files. So you need to create uh, a folder called data underscore row. What I will do is I will create a new folder, and you can see the process that they will call a new data row. So you see now that I have a new folder that is called new data row. And what I will do is I will download the file that is well, here you can see is a download.file, and first you specify the URL that is this one, and then you specify the destination that is a data row, and well, and also the name that we want to use, that is a portal data join. Here, well, if we click on new data row, we see that it's empty. So, but the thing is, we will update here the path. So it's a new underscore data row. So if we execute that, here when I have a file open, what if I want to execute something in the command line, I need to do press Control and Enter. And you see that this part is execute in the command line. So they said that trying URL this, the file is 2.9 megabytes, and we got the data downloaded here. So is that working for you? Okay, thank you. Yeah, there was the issue was with the folder there. So okay, there are more questions about that. Yes, with seems that with RStudio Cloud is get a different outputs, but okay. Mm, well, you said the sample for if I use summary surveys and then they come. So Do you get that output if when you type a summary surveys $6, do you get that output? The thing is that the output is could be different because I'm using, well, okay, okay, and yeah, I see yeah. The issue is that yeah, okay, first you get okay, you get a different ordering. First, you get the ones that are not defined, and then you get the yeah, then you get female and then male. Yeah, the thing is it changed because maybe with the I think it's you have a yeah, if you use a different version of R Studio, you get a different outputs. 'Cause for example, yesterday I was using an old version of R and an old version of R Studio, and yeah, everything looked. I mean, it doesn't mean that the output is wrong, but the format changed. So I mean, I don't saying that you cannot work with different versions of R. Saying that yeah, the output is could be different. So okay, I see that what I will do is I will continue. I I will I can solve the challenge. So the challenge was to change the columns taxa, genus, and genus in the service data frame into a factor. So to do that is you have to type the name of the data frame, that is a surveys, then a dollar symbol and genus. And then the segment symbol, factor, and this surveys, then the name of the data frame, and then specify the column, that is genus. And you can do the same with the taxa. So you type surveys dollar symbol taxa, the segment operator factor, and then in bracket the name of the column. So now if you type summary double M surveys, exactly, you see that the output is different. For example, if you see species, you see the length, class, mode, etc. But when we check taxa, we see that for we have a 450 bird, we have 75 rabbit, 14 reptile, etc. You have here the sorry, you have here the yeah the taxa for genus. So we have also the same. Well, we have, for example, other. That is because there are more genus. I think here this is 4. And if we type str, I mean the factor of taxa, I think is 4. If we have str surveys, we can double check that. Taxa, exactly, factor with the 4 levels. So we have a bird, rabbit, reptile, and rodent. So factors are good when you have different categories. It gives you more functionalities with that. Okay, there is a question that to explain the reordering levels. So what we will do is we will reorder the level. Well, we will reorder taxa. So for example, to see the levels or levels, you can also call them categories of surveys taxa. You see here levels bird, rabbit, reptile, and rodent. To if you want to reorder them, if what you can do is the function factor. The second here you will introduce surveys taxa, and then you can specify the levels. To specify the ordering is you type levels equal and then C, and here you specify you can put the first, for example, rabbit, reptile, rodent, bird. As you see here, levels normally are alphabetic, are ordered according to the alphabet. But if for some reason you want to put the reptile first, you can do so. And type reptile, say bird, rabbit, rodent. And then you will get a factor where the levels will be in a different order. Not sure if that answers your question. If not, we can see that later with further examples. Great. Also, you can, okay, we have seen to convert from strings, from character to factors, and also we can do the other way around. If we type as dot character, well, as you can see that we have some help in with the RStudio explaining that you can create objects of type character, etc. Well, I will click enter, and then I can type sex, and you see that the output is not a factor anymore. It's a vector of four with four strings. And normally this is well, normally you use you use strings. But for example, if you want to use you want to categorize years, you can also do you can do that. But bear in mind that years is a number, so you will need to convert first to convert to strings. Also, another feature of factors that you can create a plot very easy. So if we type plot and then surveys sex dollar symbol sex, you will see that in my, I will make this bigger. Here on the right, I get a plot of the number of female and the number of male of our study. The thing is, for example, you can see that the individuals that doesn't have a sex are not included in the plot. So what you can do is you can edit the factor called sex, and you can well, if we see the levels of that factor, we see that we have a male and female. But with what we can do is we can add the the another category that is let's say undetermined. If we type a sex, uh, the assignment symbol, add an A, and then the again sex. If I see the levels now, we can see that now we have three levels. We have a male, female, and NA. NA, I said that is yeah, like a undefined. Also, we can edit the name of the tag that we can use. For example, we can type levels, sex, and then as it were a vector, we type the number 3. So we will edit the third element of the factor and assignment symbol, and I will add this string that is undetermined. Determine. Execute that, and if I check again the levels of oops, sex, I see that we have a male, female, and undetermined. And if I plot again, no, I did need to plot. Okay, we see that we have a male, female, and determine. So yeah, this is everything with the factors. What I will do is I will talk now about how to work with the dates. And there is a library, another library that is called, maybe the library is not installed. If not, just follow the lesson and you can play a little bit with that later. So the library is called library date. So I will, to load the library, remember that you need to type a library. Yeah, there is a question at the end of yeah, today after the break, we will see how to create. That is a part of the lesson that is how to create plots. What we have done is we have type a plot and then the factor, the vector, etc. But that's the thing. You can do a lot of things with one of the things that are is this programming language is very powerful. Is also is regarding to create a plot. You can change colors. You can change the font size. You can save that in different file formats. You have a lot of different options. Today we will see only a very small part of that, but if you investigate a little bit further, you can do a lot of stuff to, for example, to change colors or to change the numbers, tags, etc. So coming back to to the library. To load the library, we will load the library date. Here also I have this warning that is the functions date, intersect, sective, and union. If I type them, these functions will use the function that is inside this library date, rather than the functions that are in this library. So this library is to create data objects. So for example, we can have my date, this variable, and we can assign that variable. We can assign the yeah today's date, for example. That if the function is ymd, that is well, you can see there it, what it does is it transforms a string that is we have the year that is 2020, month 10, and today is 21st. So it takes a string and converts that to a date. So if we use str my date, we can see that the object is a date, and we have that in that format. Also, for example, instead of introducing a string, you can introduce the year. You can introduce a year, month, and day separately. So if you use my date assignment symbol, and then the same function ymd, and then have another function that is called paste. But here you introduce the year first, 2020, then you introduce the month 10, and then you introduce the day that is 21st. And then, for example, to separate that, you can specify we will specify dash, but you can specify a bar, or you can specify whatever you want. So we will specify a dash. So if I print, well, if I print my date, yeah, we see that we have this. Why I'm showing this? Because we can do the same, but instead of giving only one string, what we can do is we can introduce columns. So we can use surveys. We can use the year column. We can use surveys the month column. Sorry. And the day column. You get there a warning that there is okay, in all of these. Well, now we can see the structure of my date, and you see that you have a vector of all of these rows. You see that you have 129 fields to parse. So it seems that there are some issues with the with the sum of the dates. So what we can do is we can investigate a little bit further why is we get this issue. So if we do a summary, well, also what we can create is we can create a new column with this. So what I can do is the thing that I have done before. I have executed before. I can create a new column called date surveys dollar symbol date, and I can save the output of the function here. So if I do that and I execute str surveys, we see that we have a new column called date, and we have all of this information. If we do a summary of that column, surveys date, also we see that you can see that having this using that type, we can play with we have the minimum, maximum, etc. And also we have 129 dates that are not a date. And we can investigate a little bit that if we see the mm, if we execute the following, that is a little bit complex, but if we can do a missing dates, this is a new variable where we will get from surveys, we will get the positions of that are sorry, I need to type is.na, and here I will do surveys dollar symbol date, and then what I will type is the C the columns that I want, that are year, month, and day. So if I execute that and then I read this new variable, we have the dates. Well, we have some dates that are not that didn't work when we pass. Can you see what is the error in these dates, or why they fail when we convert from day, month, year, well, from this to get a proper date? If you can paste that in the chat. Anyone see what is the error? That is how many days I have September, April. So here they said the 31st of September, and that data doesn't exist because September only have 30, well, only have 30 days, and the same for April that has 30 days, not 31. That's why when you try to convert this to a date, it creates a, they said that it's not a date because that date is wrong. So this library is useful to check that the date makes sense and you don't broad, for example, a month. If we see a month that is 13, 14, doesn't make sense. So, do you have any questions so far? So if not, what we have 10 more. I'm not sure if we. What we can do is we can have the break now, and we can start at mm, 20 past 11. Is that okay? We can have a 15-minute break. Or if you need more time, we can start at 11:30. So what do you think? So what we will explain later is we will see another way to check to do queries on the data, and then we will see some visualization, how to create some graphs, etc. So no opinions about that. So let's start 11. Okay, let's start 11. Let's have a 10 minutes break, and let's start at 11:20 or 11. Okay, someone will vote for 11:30. Okay, yeah, let's follow the schedule. Yeah, 11:30 is okay. Don't worry, because later we will have enough time to cover the rest of the lesson. So yes, let's start at 11:30. Thanks for the feedback. Yes, please grab a coffee, tea, or yeah, have a break. Thank you, and yes, let's see you back at 11:30. So hello everyone, welcome back. Let's continue with the course. See that yeah that as I said before, if you have any questions, please let me know. Happy to answer them. So what I will do is I will share my screen with R. So okay, what I will explain now is we will see a package that is called well, the is a dplyr deploy, which I think is could be pronounced in that way, but yeah. This package, when we install tidyverse, this package was also installed. So you will not have any problem using that package. In order to get this, to remove all the changes that we have done in surveys, what we will do is we will update the variable surveys again. I mean, we will load the CSV file again. So if we type surveys, yes, sorry. If we type surveys, the function that is called read CSV, remember with underscore, and then the name where that is in data row. Oh yeah, that one. So in that case, we will have let's say the original copy loaded, and we can work with that, just in case that there is any issue or any. So as I mentioned, we will work with the library called deploy. What I will do is maybe I can share the. We will work with that library, and we will see different functions that are called select, filter, mutate, group by, etc. Why we are using these functions rather than, because for example, if we want a column, let's say for surveys, we want the column plot ID. So what we can do is in brackets write the name of we can write the name of the column and we get the column in that way. But there is we can use the function that is called select. That is a function is in the deployed library. So select, we can, the first parameter or the first argument is the data frame that is called surveys, and the second one is the, well, second, third, fourth are the names of the columns that we want. So for example, if we want a plot ID, so we need just to type that. And if we click in enter, we see that we have that column. Also, we can have more columns. That is species ID. And also we can have a weight, for example. So you see that when we do this, we select 3 columns from the table surveys. Also, there is a way to remove columns. Because imagine that you are not interested in a record ID or a species ID. So what you can do is you can type select. Also, I insist in case that at some point you get lost or you need some more time, please let me know by chat. I will go maybe slower or I can wait a little bit. Sorry if this morning I like trying to rush a little bit, but yeah, I would like uh, to cover the most important parts of the lesson, and also later with the you can check the video and you can the recording and you can catch up with the things that maybe could be uh, confused or so. Coming back to the lesson, if we type select first the name of the data frame and then the columns that we don't want. If we don't want the column, we type the minus symbol. So we don't want a record ID and we don't want species ID, for example. So you see here that instead of having 13 columns, we have 11. We have all the columns as a record ID and species ID. Also, there is another function from this the deploy library that is quite useful, that we can get the observations. We can do some conditions. We can choose columns based on a specific criterion. So what we can do is we can use the function filter. So for this function, we can first get well, the name of the data frame, that is a surveys. And then, for example, imagine that you want all the observations that were taken in 1995. So you write a year double equal 1995. To execute that, you see that you get a data frame of 1180 rows. Yes, with all the columns. So to execute these functions, you can do this in that way, but also you can execute could be more readable if you don't write the name of the data frame each time that you want to use these functions. And also you can combine these these functions. So what you can do is you can use pipes. What is a pipe? A pipe is like you send some contents from left to right. I will write an example and I will explain this example once that you have. So what I said that you send information from left to right. So is you have first you have the data frame that is called surveys, and the pipe. Well, if you are using RStudio, you can write the pipe operator or the pipe symbol is Control Shift M, and you get that symbol. Well, that symbol, that operator, that is the percentage symbol greater than, and then the percentage symbol. Then you write, for example, imagine that you want to get the 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 the, the rows that are whose weight are less than 5. So you can filter, you can apply a filter. So if you type a filter in the documentation is done in that way. You press enter and then you leave a tab, filter, and also you can type this in the same line. It's up to you. Weight less than 5. So if you execute that, you get everything, all the rows that are whose weight is less than 5. So let's go step by step. If you type a surveys, you get everything. But if you type a surveys filter, I will write it in the same line. Sorry, weight less than 5. You get uh, the surveys filter by that function. But imagine that you don't want all columns. You only want 3 of them. You want the species ID, sex, and weight. What you can do is you can again use a pipe. You can type select, and here, if you see, you don't need to specify the data frame. You specify the name of the columns, species ID, sex, and weight. So if I do that, you get a table with these 3 columns and the weight that is less than 5. That you see that is in this case is 4. So do you have is it more or less clear how does it work? The idea is instead of using subsetting using the square brackets and getting let's say using in a matrix mode, you can do this using functions. It's like you print surveys and then you filter surveys, and you can do, well, you can do filtering, you can do select. And also this output, I mean, you can save this in a variable. Imagine that you have you want a variable called surveys small, SML, right? We can assign that to a variable, and if we type surveys SML, we get that table. So now is time for a challenge to see if to practice that. Give me a second that I will share the challenge with you. So please, now that to see if you to practice this, using pipes subset the surveys data to include the animals collected before 95 and retain only the columns year, sex, and weight. And yes, if you have any questions or if you have done the challenge, please write so in the chat. Great, I see that some people have done the exercise. We will wait 1 minute more and we can continue with I will explain the solution and I will explain the next function that is called mutate. Okay, what I will do is I will explain sorry, I see that, yeah, I didn't leave enough time for the challenge, but yes, I will. The thing is, we will solve this challenge together. Yeah, if you have any questions, please feel free to ask. So let's see. Okay, the challenge said, uh, okay, subset the surveys. So yeah, this. And okay, I write the pipe to include the animals collected before 1995. So I need to filter surveys. So filter. So they said before 95. So the year should be smaller than 1995. And then from that, we needed to select year, sex, and weight. So I type again a pipe, and it's select year, sex, and the weight. Whoop. So yeah, that's the exercise. You will see that this syntax, or well, maybe if you are a little bit familiar with SQL, is similar because we can tomorrow we will see that we can use select and also we can do some filtering, etc. But yes, this will be for tomorrow's lesson. Okay, so next that I like to explain is we can mutate. With that function, what we can do is we can create new columns. And why we want to create these new columns? Because, for example, you have the weight in grams, and you want the weight in kilograms, or you want the weight in pounds, or yeah, I mean, you want to create a new column and use that column, for example, to do to create a plot. So okay, a way to do that is also we will do that using pipes. So we type surveys, that is our data frame, right? The pipe, and then I want to create two new columns. I want to create well, first the function that is called mutate. I open brackets, and to create okay, I will create the column that is a weight underscore kilograms, kg, that is equal our weight. This is the column that we have in our data frame divided into 1000. So if we execute that, we will get the where they are. You don't see the. Not sure if I make this. No, you don't see the column, but you can see here that instead of 13 columns, we have 14 columns. And also I can do, well, actually, I can use a pipe, see if that works, and use the function head. Well, here in the comments you can see that there are 4 more variables: species, taxa, plot type, and weight in kilograms. And also I created only one column, but I can create two. To create 2 columns is in the function mutate. I give one argument, I can give another argument called weight pounds. Weight in pounds is equal a weight. Also, I can use the previous column that I have created, kilograms, multiply by 2.2. So you see now that the data frame that we get has 15 columns, and I can do, if we want, if I type the pipe, that is this, I can do select, and I can select weight, kilograms, and weight in pounds. Well, okay, at the beginning most of them are not a number, but here you can see that we have an animal that is around 200 grams. Here the weight in kilograms, and here the weight in pounds. So here there is okay, I will give you some time to do. There is a challenge. I will change the application that I'm. So okay, this is well, this is a little bit complex. This is you need to create a new data frame from the service data that meets the following criteria: contains only the species ID column and a new column called hindfoot cm centimeters, containing the height length values converted to centimeters. Is in that column no NAs and all values should be less than 3. The challenge here is to do a good order of the pipes. So first you need the surveys, and then you need to do some filtering, mutate, select, etc. I'll give you some time, and please let me know when you finish with the challenge. Okay, in order to continue with the lesson, I will let's solve this challenge together. So I will share the RStudio screen. The thing with this challenge is that you need to go step by step, because maybe you want to write everything, or this you want to write the solution at once, but what I would recommend is to go step by step. So first is we need a surveys, that is our the data frame that we will work with. I need the pipe symbol, and the challenge said that we want to remove the well said that is need only two columns, species ID and hindfoot CM. That this is a column that we calculate. And also they said that they don't want uh, not a number values, and the value should be less than 3. So what we will do is first I will filter that I will do the filter of we will remove the values that are not numbers. So to do that, I can use a filter, and as we seen yesterday, we can use the exclamation that is not is NA, and then the variable that is hindfoot length. So if I do that, I get the subset, a smaller data frame of a surveys, but the hindfoot will be will contain only numbers, will not contain missing values. Now that we have that, okay, I will create the new column. So the new column, to create a new column is mutate, and the new column will be called hind foot underscore CM. That will be equal to okay, will be equal to hind foot length divided by 10. And then I close the bracket. Okay, so now we have the surveys, smaller subset, and we have a new column, as you can see here, input CM. Now the exercise said that the value should be less than 3. So what I need again is to type I need to type the, okay, what I will do, I think will be like you can read this better. I will write this here. Here you can see better. Have written surveys, we have the filter, have a mutate, and now I need to type again a filter, because we want to filter the values. Sorry, I will use the new column. We want the value should be less than 3. So I type less than 3. So if I execute that with pressing Ctrl and Enter, okay, so here we see that we have executed this, and we see that okay, before we have a 31,000, and when I do again the filtering, I will make this bigger. the data frame that I get is 15,000, but I get or columns, and the exercise said that no, I only need 2 columns. So what I can do is write a pipe again, and then select species ID, the new column that I create. So if we execute this, okay, so Control Enter. You see that I execute this, and now I get species ID, CM. I get that table. So yeah, this is the answer for this challenge. So the idea of doing that is going step by step. If you do everything at the same time, it will be more challenging for you. So what's next? We can, she said that R is a good programming language for to get some statistics, and we want to see the average weight of the animals divided by group by sex. How we can do that? So if we type surveys, okay, here, well, okay, we'll do this here. So if we type a surveys, and then I will use the function, a new function called a group by. I will group by sex. Then I type again the pipe operator. And what I will do is I will use another function that is called summarize. And I will calculate the average weight, the mean weight. So this will be, I write the name of the variable, and I will use the function mean that we used yesterday in the lesson. So I will use a weight, and also I will remove, as you remember, I will remove the values that are not a number. I will say true. So if I execute that, you will see on the bottom, you will see that yeah, we have executed this function, and you see that we have a sex, and we have the average, the mean weight of. So you can see that for the species that we don't have a value, the average is 64. For male animals is 43, and for female is 42.2. And also we can, okay, in this case we made a group by sex, but we can use several columns. So if okay, we'll copy and paste this. Here I can add sex. Well, we have already sex. I will add species ID. So if I execute that, we can see that we have a group. Well, first we have a female, and then we have the species ID. So for this species ID, the average is 9.16. For this one is 41.6, and so on. Also, there are in the documentation you can you will find further examples where there is you can get, for example, here. This is important. You can calculate the average, but also you can get the minimum. So you can do so if you copy this part and change the mean with the minimum weight, minimum. So if you execute that, you get the two columns. You get the minimum, sorry, the average, and you get the minimum. Also, you can there is ways to you can short the minimum if you but for this you need to add a pipe symbol, and you can use another function that is called arrange, and you type the minimum, the column that you have already calculated. So you see that now you get this this is short by the minimum weight. So first you get 4, then get 5, 6. So you have all of these choices in order to filter and group and get what you want. Also, what I will, because I would like to see a little bit of the visualization of the data, I will explain counting, that also you can count. To count this, you get surveys, and then count can count by sex, for example. You execute that, you can get this table. You can get a table where sex is a column and then the count is another column. So for females you have this number of animals, for males you have this number, and from NA you have this number. So what I will do is, okay, I will finish this part of manipulating data, and we will see some visualization. So what I will do is I will show you the documentation. Well, here is explained all of these samples, and also there is a small challenge. Here in the last part, we have a reshaping with the gather and split. The thing is, well, you can see that later. For example, imagine that you have this table. You have a column that is a plot ID, you have a genus, and you have a mean, the average weight. But imagine that you want to spread, you want to create a table where you got the plot ID 1, 2, 3, and each of the, so now the genus column, so I mean the values of the genus will be the columns, and then you get the average weight. So you can do that using the function spread. Also, you can do the other way around using the function gathering. Imagine that you have this table and you want to gather all of these results and create a new column called genus, and write the average weight. So the mean weight. So you can do this using that function. You can see that later, and if you have any questions, you can ask there tomorrow or in the consultancy session next month. So what we will see is to export how to, once that we are happy with our data frame, how to save that data frame in a file, because that file will be used later in the visualization, in the data visualization. So okay, we'll switch again the screen. And in order to save time, I will copy the so okay, if I want to clean because if I type surveys, I get the original data. Okay, we'll type here on top of in this window. But what I want is I want to clean this to clean this. So what I will generate a new a data frame, and the variable will be called surveys slash complete, that will contain surveys. And what we will use pipes to clean this survey. What I will use a filter, and I will get rid of the weights that are not numbers. So I type the exclamation symbol is .na weight also. I want to get rid of the values that are not that are missing of hint food. And the values that are missing of sex. Okay, so if I execute that, I will get, now I can type a service complete. And we see that we see that the number of rows is smaller. Also in the documentation said that we can filter and get we can see that the count, the animals that should be on this should be observed more than 4 times. There are less, we can do the filter. So what I will do is I will copy straight from there so this is you extract the most common species ID, doing you do the count, and you do a filter, and then you filter again service complete, saying that the species ID should be in species count species ID. So first you execute this, then you execute this, and now you have your data frame that is called service complete is cleaner, and is you can use that you can save that into the disk. To save that, you need to write. I will copy and paste. Write underscore CSV, the name, service complete, and you just have to specify the file. File will be in data service complete. So if you execute that, Control Enter, you will see that in our files, if we go to data, you see that we have a service complete. And you may remember that the file before was where the original file is 2.9, and this file is 2.1. So see that is reduced. Do you have any questions so far? If not, I will continue with the visualization. The visualization part is quite long. You have a lot of choices in order to create a plot. You can define colors, or you can define the axis. You can do a lot of things. We will see a few of them, and you can play a little bit with the. So okay, because we already loaded the tidyverse library, we have the ggplot library. That library, I think it's called ggplot2. That library is to create visualizations. So to create a plot, and also you can save that plot with good quality to use that in for your research, in your paper, web page, etc. So we will use, as I said, the service complete. So I will explain how to use a ggplot. Is well, first, okay, I will type this here on top. So it's a ggplot, and first we need to specify the data frame that we want to print. So data equal, and we say the service complete. That is the data frame that is cleaner for that. Then we need to specify the mapping of the mapping means that which variables we will use, etc. You will understand. So it's a mapping. We need to specify mapping, and is we will use the function as, and then we will specify here the x and y of our plot. So x will be equal weight. Sorry. And the y will be equal input length. So if we click in control, okay, there is an error because they said that the object input length is not found because I wrote a typo. That's the right way of. So, well, let's go step by step. I'm not sure what I will work with this. If I execute this, I get this plot that is empty because we didn't give the mapping. So if I specify the mapping, we see that in the X uh, we have a weight, and in the Y axis we have the hint for the length. But also what I need to specify is the data, how I will write the data, how I will plot the data here. So I needed to do that. I will copy and paste. I needed to add. Okay, I may add the geometrical form that we will use a point in that one. So if I execute that, you can see the plot that we generate. That here the I using as a geometrical form. We are using points. Also, what you can do is this first part. You can save the first part in a variable called surveys plot. To do that, and then you can do the surveys plot, and then you can define the how what do you want to use. So you can do that, and yeah, you get this. You get this. Also, for example, this is what they said that R has a lot of features. Here, you get these points like a quite, let's say, quite thick, but you can use some transparency. So to this function, you can use the parameter alpha equal 0.1. So if we execute that, you see that the plot looks different. We'll make this looks different. Also, there were a question about the color. You can also change the color. You can specify color equal blue. Also, an interesting thing that you can do is you can color according to the species ID. You can give a different color. So how can you do that? You remove this part of a color, and you can type again as this function, and you can specify color equal species ID. Oops. So if you execute that, you can see, well, I think maybe I can, no. You can see that depending of each code, you can have for example, we have a species ID here, another species ID here. You have this, each color is an ID, a species ID. Also, this is to build this type of graph, but also you can build blocks blogspot. You can change. You can use ggplot. Data will be the same. Will be surveys data equals surveys complete. The mapping. Sorry. Equal as. And here we will specify that X will be species ID and Y will be weight. And then instead of use geom point, we will use geom box plot. So if we execute that, we will get in the X axis, we get the species ID. In Y, we get the weight. And here you get a box plot for each. Also, if you want, you can add a point to the box plot in order to get. I'm doing the samples that are in the documentation, but you can find that are many of them in other documentation or in. So to do that, I needed to modify alpha, that is equal 0, and use another geom that is called getter, and we can specify alpha. Alpha, remember that is the transparency of the. Also, you will not remember everything of this. So normally when you want to create a plot, you check the documentation and you find the things that you like to do. Can specify 0.3 color. That is color tomato. Yeah, it takes some time to. So as you can see, well, behind this you have the box plot, and on top of that you have a point, and you can see you can have a better idea of the distribution of the weight. What I can do is because I could stay here until 1 p.m. or the whole day, like doing different types. What we can do is we can go through the documentation. I will save as an example. I will save a plot, and you can ask me any questions that you may have. So I will switch my screen. So you can find here the different plots that we have done, other box plot. Also, we can plot time series data. Remember that is always ggplot, data, then the mapping, and then you specify the geometric form. In this case, we have a line, and what we are plotting here is year. We have the count of animals per year. So you see this form, but yeah, it doesn't look quite nice. So also you can get this by divided. You get a line per genus. The problem is, for example, here you get all of them of the same color. So also you can get something like this, and you get yeah, you see, for each genus which what is the count for each one. Also, you can use the pipe operator with the ggplot, and you don't need to specify here, because if you remember, we specified ggplot, and the first variable was the data frame. In this way, you don't need to specify that. Also, we can create for each there is a question if we can do a CD plot. I think so. I'm not sure if this is covered in this documentation, but R is quite powerful in creating visualizations. So I think it will be can be possible. I can check later an example of that and write that in the in the chat that we have. Oh, yeah, Chloe found an example of a 3D plot. So as I said, for example, we can have for each genus, we can have a small plot. Also, we can split by sex and have a different color. I mean, you have so many ways to you can do face it both by sex and genus. So yeah, you have plenty. And here, what I recommend you this afternoon or any time that you copy and paste and play a little bit with this, because you can do lots of visualizations with. And also you can use here they explain that you can use themes to get. Also you can customize. For example, you can change the label so that you can specify the title of the x-axis, the title of the y-axis. So for example, you can create something like that. This you can create this plot is of a very good quality, and if you print that, is well, very good quality. Not this one. If you see here, the years are quite. The font is quite big. So also you can edit, and you can make the font. You can change the direction, so you can print the year in that way. So you can see that you have many ways to do to create a plot. Here what is explained is if you use this library, you can create two figures two plots and put them in the same figure and generate the same figure. Before I finish, I have to explain how can you save this. What I will so to save a plot, you use the function ggSave. So I will switch my screen. So what I will do is I will copy this here. Okay, we'll execute this, my plot. Okay, it complains that this is not. Okay, well, what I can do is I can use another example. I can use, for example, this one that is the tomato one. I will copy this here. Okay, you can use one of the samples that we have seen before. Thing is, I will save this in the variable my plot, the assignment, and I save this. I will make this bigger. So okay, I got this plot, and I will save this in my plot. So if I do that, yeah, should work. And if I use my plot, sorry, enter. You see in the right hand side that the plot is again generated. So how to use? I will use ggSave. The first argument is let's say my figure dot png. I had to specify what I want to save. That is my plot. And then I can specify the width. Let's see if that is okay. One. Let's say 10. Also, I can specify DPI. That is 300. For instance, the quality of the picture. So let's see if that works. Yes. So if I go files, you can see that we have my figure.png, and if I click on that figure, I'm not sure. Well, okay, you cannot see there, but I will. Okay, I will switch the screen. I think is I got this figure. But for example, if I don't like the color, so I generate again the color and I can save it again. So you can see that now this figure can be used in a paper, web page, etc. So to finish this part, yeah, because was a question about the 3D the 3D plots. We will see an example. My colleague Claude said that there is a well, this blog is quite good for people interested in art, and we can see with that you can generate 3D plots. Well, you can see some examples. Oops. Yes, you can see that. Yes, you can generate. Well, you can generate all of this stuff. So, do you have any questions? This is our well. This is a small summary of things that we can do with R. Sorry if I rush a little bit with the lesson, but yeah, we like to cover everything, and then you can have a time at home, or if not this afternoon, later, or any other day that you can check the documentation and you can go to the samples and you can, but at least you have a view of what we can do with R. We can get a set of data. We can get rid of the data that we don't want. We can clean the data. We can create new columns, etc. And once that we are happy with that, we can save that, and also we can create some plots. Yes, this is an example of what we can do with R. If you have any questions, please feel free to ask them, or if you have the questions later, you can type them on in the chat. The chat, I remember that is here in the. We'll copy the. If you go to the course web page, chat is here. Is the collaborative notes. So you can type here the. Or well, you can ask me tomorrow. Okay, I see that there are no questions, and I guess that yeah, it's very close to our end of today's session, and also yeah, I think we are all of us a little bit hungry, so it's lunch, a deserved lunch. So well, thank you so much for staying today with us, and tomorrow we will work with SQL. This lesson will start at 10, but if you have any issues with the installation, I will be around since 9:30. So please feel free to connect before. And I have a question regarding the upload. That is, yes, yesterday and today's session will be uploaded to YouTube. So yes, this afternoon or tomorrow morning we will upload the lessons. So yeah, thank you so much and have a nice rest of the day. See you tomorrow to learn a little bit more about SQL. Thanks. Bye.